We've seen this example before in the section on dividing polynomials. We noted at the time that the remainder was 0 and that this was an important feature. If we consider numbers for a moment, if we do 12 divided by 4, we get 3 with a remainder of 0. And if we do 14 divided by 4, we get 3, but we get a remainder of 2. This happens because 4 is a factor of 12, but 4 is not a factor of 14. So we get a remainder of 0 when a number is a factor of a number it's dividing. If we now consider these polynomials and doing this division, when we did the division we had a remainder of 0. It follows that x minus 3 must be a factor of this expression, just as is the case with numbers. Note that 4 times 3 is equal to 12. With our polynomial, this means that x minus 3 times something must be equal to the x cubed minus x squared minus 2x minus 12. And if we call this f of x, we could write this as f of x being equal to x minus 3 times something. F of 3, if we evaluated it, would be 3 minus 3 times the something, and since this is 0, it would be 0 times something, which is 0. And this, as we'll see, is an important feature. If we now consider this example, it follows that 2x plus 3 is a factor of this expression because of the remainder of 0. If we say that f of x is this expression, then it must be equal to 2x plus 3 times something. If we evaluate f of minus 3 over 2, then we get 2 times minus 3 over 2 plus 3 times something, and this is minus 3 plus 3, which is 0, times something, which is 0. It follows that generally, if we have f of x is equal to ax plus b, so ax plus b is a factor, times something, then f of minus b over a will always be equal to 0, because subbing minus b over a in here gives 0. For example, if we had f of x equal to x plus 2 times something, then f of minus 2 would be 0, and this would tell us that x plus 2 is a factor if we didn't know that fact already. So it works both ways. Without doing the division, if we know that f of minus 2 is 0, we know that x plus 2 is a factor. In the same way, if we knew that f of minus b over a was equal to 0, we'd know that ax plus b is a factor. And this is the factor theorem.